Good morning, students. Welcome back to our discussion on chapter 2, polynomials. This is the last part of our discussion on this chapter. So let's proceed. Today, let's continue our discussion on exercise 2.3. Last time we already finished question number 1 for finding quotient and remainder when one polynomial is divided by the other. Today, let us discuss three important questions. Question number 2, 3, and 4. In question number 2, we have to check whether the first polynomial is a factor of the second or not by division process. And in question number 3, we have to obtain all the remaining zeros of the biquadratic polynomial when two of its zeros are known. And in question number 4, we have to find g of x. G of x means it is the divisor when quotient, remainder, and dividend are given. So let's continue to find out the solutions of these questions. First, let us solve question number 2, Roman number 1. Okay, solution. All of you know that a number or a polynomial becomes a factor if the remainder of 10 is 0. So here I'll give you one simple example again. When 4 is divided by 2, the quotient is 2 and remainder is 0. That's why we say that 2 is a factor of 4. Likewise, in polynomial also, we have to check whether the remainder come out as 0 when the first polynomial is divides the second polynomial. So to proceed division, let us write the divisor in the standard form by inserting the missing term with the help of coefficient 0. But it is not compulsory to do all problems this way. You can do directly also. Okay, so let's proceed. Here the highest power term of the dividend is 2t to the power 4 and the highest power term of the divisor is t square. So proceeding the division process, the first term of the quotient becomes 2t square. Continuing this way, the second term of the quotient becomes 3t, and we continue till the remainder and the degree of the remainder is less than the degree of the divisor. But here we see that the remainder is 0, and it means that as the remainder is 0, therefore we can say that this divisor, that is t square minus 3, is a factor of the given biquadratic polynomial. Next, let us solve question number 3. First, let me read the question. Obtain all other zeros of 3x power 4 plus 6x cubed minus 2x square minus 10x minus 5 if two of its zeros are square root of 5 by 3 and minus square root of 5 by 3. For a biquadratic polynomial, it may have 4 linear factors. Therefore, we can have at the most 4 zeros. As 2 zeros are already given, so we have to find another 2 zeros if possible. But as you know that if we can't have 2 zeros, it means that we can have a quadratic polynomial corresponding to these zeros. So first let us find that quadratic polynomial, and by that quadratic polynomial let us divide to the given biquadratic polynomial. So let's continue. Yeah, and the given polynomial is p of x, and the given zeros are square root of 5 by 3 and minus square root of 5 by 3. To find the corresponding quadratic polynomial for this, let us find the sum. The sum is 0 and the product is minus 5 by 3. So using the formula, a quadratic polynomial is k times x square minus sum of zeros into x plus product, where k is not equal to 0. And if I proceed and then taking k equal to 3, I have got the answer as 3x square minus 5. But here you can do as an alternative method also without taking k. you can directly proceed with the polynomial x square minus 5 by 3 without taking this k. Both the answers will remain the same, but you apply or think for that convenient one. Here the divisor is 3x square plus 0 into x minus 5. Here I have inserted 0 into x to make convenient for division process. And the highest power term of the dividend is 3x power 4, and the highest power term of the divisor is 3x square. So if we divide this, then we have got the answer as x square. What will this x square be? This will become the first term of the quotient. So by proceeding this way using division process, again for the second term we have got the s twice x. So proceeding this way we observe that the remainder is 0 finally. Here p of x becomes our dividend. So our dividend is equal to divisor into quotient, and the first factor is 3x square minus 5, and the other one is x square plus twice x plus 1. Divisor into quotient plus remainder is 0, so you need not write here 0. Now from the first it is already given that the zeros are square root of 5 by 3 and minus square root of 5 by 3. So the other two zeros can be obtained from the second factor. The second factor is x square plus twice x plus 1. So using a plus b whole square formula, so we can write as x plus 1 whole square. It means that the factors are x plus 1 and x plus 1. So from these two factors we can get the zeros as minus 1 each. Therefore finally we can say that the remaining zeros of the given polynomial are minus 1 and minus 1. Next let us solve question number 4. On dividing x cubed minus 3x squared plus x plus 2 by a polynomial g of x, the quotient and remainder were x minus 2 and minus twice x plus 4 respectively. You find g of x. Here g of x is our divisor. So what is given in this question? Dividend, divisor, quotient, remainder. Out of these four, dividend, quotient and remainder are given, and we have to find g of x. For finding the answer of this, let us remember the formula once again, the relation once again. That is, dividend is equal to divisor into quotient plus remainder. So from this let us make a formula for divisor. What will be divisor? Divisor will be dividend minus remainder divided by quotient. Again putting the respective values of dividend and remainder, we got the answer as x cubed minus 3x squared plus 3x minus 2. Now this answer is to be divided by the given quotient x minus 2 to get g of x. So as we did in the division, x minus 2 becomes here divisor, and the given dividend minus remainder becomes the dividend. So the first term is x cubed, and for the divisor it is x, so we have got x squared. This becomes the first term of the quotient, and after subtracting we have got the second term, third term, like that. Finally here the remainder is 0, therefore we can say that this x squared minus x plus 1, this is our answer for g of x. So g of x is x squared minus x plus 1. Thank you all for today.